Hello dear students, welcome back to our physics class, and I'm so excited to see you again in a new lesson. Today's lesson, we will continue solving the questions which is related with the centripetal force. As you know, in a previous lesson, we studied the centripetal force, which is the resultant effective force that acts on a body when it's moving in a circular path. This direction is always directed toward the center, which causes the centripetal acceleration. So the angle between the centripetal force and the centripetal acceleration is zero and always parallel to each other. For every circular motion, the object requires a centripetal force. Without centripetal force, the object cannot maintain in a circular path. So we have many sources that provided the centripetal force, which is, for example, the gravitational force between the planets or between the Earth when it is orbiting around the Sun. Which of the following forces, which of the following force provided the centripetal force when the Earth orbiting around the Sun? The gravitational force. Without gravitational force, the Earth is moving in a straight path. Okay. Another source of the centripetal force is the tension force. What is tension force? The force of the rope. For example, when a ball is tied at the end of the string and the string is reeled in a circular path. Because of this rope, this string, which is provided the centripetal force, the object is moving in a circular path. Okay, such as this ball. Okay, look at this ball. In this example, the centripetal force provided by the tension of the tension force, which is the rope. Okay, in the case when the rope is break, for example, the object cannot maintain in a circular path. Instead, it's moving or fly off in a linear path because of the inertia. Okay. In a previous lesson, we stopped it here. Okay. Question 26. This is very good question. Be careful, and it has been brought many times in the Wizari exam. Okay, so pay attention and listen carefully, please. But before solving this question, as usual, we have some note which is related with this question, because there is a small trick in this question. At first, we have to read the note. If an object is moving in a circular path and it is maintained in a circular path under the effect of what? The effect of the gravity. For any object, when it is maintained in a circular path under the gravity, we have to equalize the gravitational force with the centripetal force. Look at me. When does Fc is equal to Fg? When the object maintained under the effect of the gravity. Okay? So in that case, Fc is equal to what? We studied Fc is equal to a Vt squared over r. Fg is equal to gravitational force is equal to mass times gravity or free fall acceleration. Okay, so these two mass cancel to each other. Okay, what does remain? Vt squared over r is equal to g. Cross product, 1 times Vt squared. Vt squared. G times R, GR. Times radical to remove the square. To remove what? The square. It becomes what? The square Vt and the radical, GR. Radical with the square cancel. What does remain? Vt is equal to GR. Maybe the student says, is it possible to write down this equation without proving when the question says the object maintained in a circular path under the effect of the gravity? Yes, of course. Okay, so you don't require to write this step, because in the Wizari exam is a multiple choice, so that is why you can use this equation. When does this equation can be used to find the tangential speed? When the object maintained under the gravity. Okay? Okay, let's get started solving this question. Question 26 from chapter review, very good question. Okay, it has been brought many times. Be careful, please. Listen carefully. A roller coaster car speeds down a hill past a point A. Okay, Look, this is, for example, when the car is here, okay? At point A, the distance from the axis of rotation is 10 meters. RA is equal to what? 10 meters, okay? Then rolls up a hill past point B. After a while, the car reaches point B. This is point A, this is point B, okay? As shown in this figure. The figure is shown here, okay? So in the exam, they will give you the figure. The car has a speed 20 meters per second. What is this? This is speed, tangential speed. Vt at which point? At point A. Okay, it means that Vta is equal to what? 20 meters per second. Okay, if the resultant force, what do you mean by resultant force on the car? Okay, directed toward, which force directed toward the center? Be careful, please. We have many different types of the force, like normal force, frictional force, gravitational force, centripetal force, static frictional force, okay? So it is very important to indicate this force is which force. The resultant force, if you remember, okay, when we defined the centripetal force, we said is the resultant effective force. So which means that this force is a resultant force. Also, you can recognize this is Fc by another way, directed toward the center. Which of the following forces directed toward the center? It means that this object is moving in a circular path, the centripetal force. What is this force? Centripetal force. How did you know? Because the question said resultant force and directed toward the center. Directed toward the center, okay? This is Fc, which is equal to 206 times 10 power 4 Newton. At this point, at point A, okay? And directly toward that. We have two hidden here, two unknown. A, what is the mass of the car? What is the mass of the car? A, mass of car is unknown, okay? B, what is the maximum speed the car can have at point B? VTB. For the gravitational force only to hold it on the track. So, what is maintaining this car in the circular path? The gravitational force. As I prove it for you, when the gravitational force is provided for the centripetal force, or when the car maintained in a circular path because of the gravitation, so you have to use this relation to find Vt as the G times R. Okay? Let's solve branch A. Okay, to find mass, because the centripetal force is given, Fc is equal to what? Is equal to m Vt squared over R. Okay, rearrange this equation, cross multiply. 1 times mVt squared, mVt squared is equal Fc times R, FcR. What is unknown? M. Okay, to find m, this Vt is go to the denominator, Vt squared. So what is remaining in the denominator? Fc times R. So do we have Fc? Yes, was given 206 times 10 power 4 times. Do we have the radius of the circular path? Yes, was given according to the figure, as you can see in this picture. So divided by Vt also was given. 20. This tangential speed is the speed at point A. Be careful, okay? At point A. Okay. 20 square, don't forget this square, please. By calculator, the mass is equal to what? 515 kilogram. Okay? So you can solve branch A in this way. It's too easy, okay? Branch B, to find, sorry, what is unknown here? VTB. Because the tangential speed at point B is different from the tangential speed at point A, okay? So how can you determine VTB when the gravitational force only to hold it on the track? Okay, what is hold the car on this track? The gravitational force. So that is why you have to use this relation. Okay, FC, which is equal to what? FG. mvt square over r mg. Mass cancelled. Vt square over r g. Vt square is equal to, Vt square is equal to g times r. Time is radical both sides. To remove this square is equal to gr, which is g is constant. R for point B is different from point A. Be careful. Is equal to 15. RB was given. RB is what? 15 meter. Okay? 15 meter. So in this way you can finding the VT, which is equal to, it should be less than point A because the object is moving upward and its velocity decreases. When the object moving upward, what happened to the velocity decreases because of the gravity. 12.1 meter per second. Okay, 12.1 meter per second. Okay, so you can screen this solving if you want. Okay. About the circular motion and the centripetal force, we have these two notes. It's very important. Be careful. When an object is moving vertically in a circular path at maximum point, for example, when a car is placed here, okay, in that case, where is the gravitational force? The gravitational force is always directed downward toward the center. Centripetal force also downward. Okay, the centripetal force, this is centripetal force, Fc. Okay, so what about the normal force? The normal force is always perpendicular to the surface of the object. Is always what? Perpendicular to the surface of the object, which is opposite direction of the gravitational force in this case. Be careful. Okay, so how can you determine the equation of the centripetal force when the object located at the top, when at top point, Fc is equal to what? Fc, which is directed toward the center, so that is why you have to consider the positive, is equal to what? Is equal to Fg minus Fa. Why normal force is negative here? Because it is directed outward of the circular path. For any forces, when directed toward the center, it should be considered as a positive. Okay, when does the force become negative? When the force is away from the center of the circular path. Okay, when the force is directed outward from the circular motion, it should be negative. Okay, so Fc is equal to what? Fg minus Fa. But in the case when the object at the lowest point, for example, when a car is here, okay, so or let me draw another figure, okay. For example, when a car is moving, okay, so and when a car is moving, trace the circle, okay. So this car has a gravitational force always downward. At the top, also downward. At the bottom, okay, at the lowest point. Object at lowest point. Object at lowest point. Okay, so the direction of the gravitational force directed downward, The normal force is perpendicular to the surface. Always, this is normal force. Centripetal force is always directed toward the center. Same direction of the FC. What is the difference between these two cases? The main difference in these two cases, in this case, the gravitational force has the same direction of the centripetal force when the object at the top of the incline, okay? But when the object at the lowest point of the hill, normal force has the same direction of the centripetal force, okay? So how can you determine FC? FC is equal to what? What is with FC? Which force has the same direction of the FC? Fn. So that is why you have to take Fn as a positive, and Fg in that case is negative. Why Fg is negative here? Because it is outward from the center. But why Fg is positive here? Because it is toward the center. Okay? And also you can consider that the Fg is negative here, okay? But by multiplying by the negative one, you can get also this equation. So at the lowest point, Fc is equal to what? Fn minus Fg, okay? And also, I mentioned it here. But for the roller coaster, the situation is completely different. Be careful. For the roller coaster, the situation is completely different. How? Look. In a roller coaster, for example, when the motor skill is moving in this direction, at point, how many points do we have? We have 4 points, okay? Point A, or 1, sorry. This is number 1, okay? This is number 1, okay? At the highest point, at the lowest point, this is number 2. At the middle, this is number 3. Both are the same, okay? For number 1, where is the object? The object is upside down, okay? When the motor skill is moving upward at the top point, the motor skill becomes what? Becomes upside down, okay? In that case, where is the gravitational force? Downward. Fc, also downward. Normal force, perpendicular to the surface, also downward. So it means that all forces are downward, okay? When the object upside down here, okay, as you can see in this figure, look, where is the centripetal force? Downward. Fg, also downward. Normal force, perpendicular to the surface. Where is the surface here? Also downward. Okay, how can you determine Fc? Fc is equal to what? Because all forces toward the center, which is equal to Fn plus Fg. Okay, is equal to what? Fn plus Fg. At the lowest point, the situation is completely different. How? Look. At the lowest point, Fg downward, Fc and Fn is upward. Fc is equal to what? Is equal to Fn minus Fg. Fc is equal to what? Fn minus Fg. But at the middle, only the normal force provided the centripetal force. Be careful. Okay? Only the normal force provided the centripetal force. Okay? Okay, at horizontal, gravitational force is downward. What is this? This is centripetal force, which is provided by the normal force. Careful. This is action force, and this is reaction force that created the normal force to maintain the car in a circular path. So in that case, so we have to, so it's not allowed to count Fg. Why? Because Fg is perpendicular to the centripetal force. The perpendicular force or vector cannot be counted to find or to calculate the centripetal force. Okay? So that is why only the normal force provided the centripetal force. Be careful. This is very important, please. Which forces provided the centripetal force? Only the force that in same direction of the centripetal force or opposite direction of the centripetal force. Okay? So why in that case Fg effect is the centripetal force? Because it is opposite direction of the centripetal force. But the perpendicular force will not affect the centripetal force. Be careful. Okay? Question 29. Look at this question. Listen carefully, please. An airplane is flying in a horizontal circle. In which circle? Horizontal circle. At a speed 105 meters per second, which is Vt is equal to what? 105 meters per second. The 80 kilogram pilot. What is this? This is mass. How did you know this is mass? Because of the units. Is 80 kilogram pilot. So the 80 kilogram pilot doesn't want to centripetal acceleration to exceed 7 times free fall acceleration. What do you mean by the centripetal acceleration AC? To exceed what? 7 times free fall acceleration, which means that AC is equal to 7 times free fall acceleration. It means that gravity, it's constant, 9.81. Be careful, this is very important. In this question, the centripetal acceleration is given, but indirectly, okay, not directly. The centripetal acceleration is given and it says does not want to exceed 7 times free fall. It means that AC is equal to 7 times gravity. Free fall acceleration, it means that's gravity, okay? What is unknown? A. Find the minimum radius of the path. R. B. Add this radius, which is we found in branch A, in this same radius. What is the net force that maintains circular motion? What do you mean by net force that maintains circular motion? It means that this force is Fc. Careful, okay? Fc is unknown. Okay, let's get started solving this question. Listen carefully, and it is a very good question, okay? To find the radius of the circular path or the plane's path, we have to use the equation of AC. AC is equal to what? Vt squared over R. What is unknown here? R. R is equal to what? Vt squared. Do we have over AC? Okay, now. Do we have Vt? Yes. 105 squared. Do we have AC? Yes, is equal to 7 times G. AC is equal to what? 7 times G. 7 times free fall acceleration. G is equal to what? 9.81. R is equal to what? 160.5. This is the radius of the plane's path. Okay? The second unknown, B, Fc. Fc is equal to what? mvt squared over R. Okay? And you can say Fc is equal to N times AC. It's too easy. Do we have mass? Yes, AT. Do we have AC? Yes. 7 times gravity. Okay? Fc is equal to AT times 7 times 9.81, and it is equal to 5,493.6 Newton. This is the centripetal force that maintained the plane in a circular path. Okay? Another question with this note. Okay? So the picture is very important, and maybe they will bring in the Wizari exam about the circular motion of an object when it's tied at the end of the string and reel in a circular path. An object is tied at the end of the string and it's being reeled in what? In a vertical circle. The object is moving in a circular path because of this rope. Okay? What happens to the object when the string is break? At which point? At horizontal. For any time, be careful. When the object is break at horizontal, this is horizontal, be careful, okay? This is horizontal. At horizontal, when the object breaks at horizontal, the object may be moving upward or downward in a straight path. So let me ask you a question. When does the ball fly off or moving in a straight path? When the ball is breaks at vertical or at horizontal? The answer is when the string breaks at horizontal. When does the ball follow the straight path? When the ball breaks at horizontal. This is horizontal. This point is horizontal. This point is what? Horizontal, okay? But in the case when the string breaks at vertical point, y negative or y positive, when we say horizontal, x negative or x positive, when the string breaks at y negative, the object moving in a straight path or parabolic path, in a parabolic path. Why? Because of the gravity, due to the gravity. Because the gravity acts to every object and pulling downward, so that is why the object cannot maintain in a straight path. So that's why it's moving in parabolic motion. In which of the following case, when the string or the rope is breaks, the object follow the parabolic motion? When the string breaks at vertically. Okay, when the string breaks at negative y or positive y. Okay? A ball is wheeled in a vertical circular path on the end of the string. When the string breaks at the position, figure A, the ball moves vertically upward, such as this figure, or downward, such as in figure B. But when the string breaks at the top of the ball moves along the parabolic. What do you mean by at the top of the ball? Vertically. Okay? An object is tied at the end of the string and it's being wheeled in a horizontal circle. What happens to the object when the string breaks? At which circle? Horizontal circle. At any point when the object is moving, this is horizontal, be careful. Nice, look at me. This is horizontal path. In this case, when the object is moving, or when the string is breaks, the object follows a parabolic motion. Okay? So, but when the object is moving perpendicular at the top point, the object is moving in a parabolic motion. Okay? But when an object is tied at the end of the string and it's being wheeled in a horizontal circle, in that case, the object is moving in a straight, the string breaks at each point, the object is moving in a straight linear. Okay? As I mentioned before here, okay? So, sorry, this question related with, for example, at the horizontal, which means that at this point, when the string breaks at this point, the object moving straight line, okay? And at this point, the object is moving directly downward. But in horizontal path, when the string breaks, the object follows the parabolic motion. Okay? Okay, rotational motion of object. Consider a car approaching a curved exit ramp. Okay? To the left. At a high speed, as the driver makes sharp left turn, the passenger slides to the right because of the inertia and hits what? Hits the door. Okay? So at that point, the force of the door keeps the passenger from being ejected. Why? When you make the sharp left turn and the car is moving very fast, in that case, the passenger will hit the door. Why? Because the frictional force between the chairs and the clothes of the passenger does not enough to keep the object at its position. So that is why the object tries to move away because of the centrifugal force, okay, because of the inertia. But because of the door, okay, they keep the passenger from being ejected from the car. Okay, so it means that in that case, when the car is moving in a circular path, which of the following provided the circular motion? The door of the car, and the seat belt also. Okay, in the case when the car is moving very fast. But when the car is moving very slow, what are the forces that keeps or maintaining the object or the passenger from being ejected from the car? The friction between the chairs and the clothes of the passenger, and the force of the door that keeps the passenger from being ejected. Okay, so from the car. Before the car enters the ramp, the passenger is moving in a straight line. As the car enters the ramp and travels along the curved path, the passenger, because of inertia and centrifugal force, tends to move along curved path. And the origin of the force that maintains the circular motion of the passenger is the force of the friction. This is in accordance with Newton's first law. Okay, what causes the passenger to move toward the door? Because of the inertia and the centrifugal force. Because of the inertia, tendency of an object to moving in a straight path, there must be force that pushes the passenger outward. The outward force is what? This force is sometimes called what? The centrifugal force. What is the centrifugal force? It's the force that acts outward from the circular path. Okay, for example, when an object is moving in a circular path, centripetal force always toward the center. But the centrifugal force, centrifugal force always toward away from the circle because of the inertia. Okay. We have two different cases here. Okay, when a car is traveling in a curved path, or object, bicycle, motor, car, or an object is spinning on a rotated table without skidding, when a coefficient of the friction is given or unknown, use the following equations. Mu s is equal to what? AC over G. Mu s is equal to what? Vt squared over Gr. Mu s is equal to what? R omega squared over G. When does this equation can be used to find coefficient of static friction? When a car is moving in a circular path, or when an object is rotating on a rotating body. As you can see in this animation, okay? Look, this is car is moving in a circular path, okay? The force that maintains the car in a circular path is what? The frictional force, okay? The force that maintains the car in a circular motion is what? Fc, which is provided Fc, okay? At this point, what is the direction of the centripetal force? Directed toward the center, which is provided by what? By Fs, okay? Or when, for example, let's discard this, okay? Sorry. Or when an object is rotating on a table, okay? Also the friction between the table and the object maintained. For example, this is the object rotating in a circular path. Also this mu is the static frictional force keeps the object in a circular path. Okay, so let's prove these three equations. It's too easy. Okay, so I suggest for you to prove the equations, okay, because you cannot memorize all the equations in the physics book. So that is why, if you have a bad time or if you are struggling in these equations, you can prove it, okay? If you prove the equations, you will not forget, okay? How can you prove these three equations? Now I'm going to prove these three equations, number 1, number 2, number 3. In that case, when the car is moving in a circular path, when a car is moving in a circular path, motor skill, bike or table on a rotating body, what causes the centripetal force? the coefficient of the static frictional force, Fs. What provides the centripetal force for a car when it's moving in a circular path? The static frictional force. The symbol of static frictional force is what? Fs. Okay? So, Fc provided by Fs. Without friction, for example, if you have a circular motion, or a circle, okay, and a circle rolls without friction, in the case of the frictionless, smooth surface, 100% smooth, okay? In that case, even if you change the steering wheel to make a sharp left turn or a right turn, the car does not turn. Why? Because of the friction. In the absence of the friction, the car cannot maintain in a circular motion. Without friction, the car or the object cannot maintain in a circular motion when object is moving in a circular path on the ground. Okay, so that is why every circular motion for a car, motor skill, bike, they require what? The frictional force, which is Fs. Okay? When a car is moving in this circular path, okay, for example, centripetal force down toward the center, and the static frictional force also toward the center. But gravitational force and normal force, they are balanced to each other. These two forces balance to each other to keep the car on a circle. Okay? In that case, Fg is equal to what? Fa. Fc is equal to what? Fs. When Fc is equal to Fs, Fg also equal to what? Fn. Why Fc is equal to Fs? Because to maintain the car in a circular motion. Why Fg is equal to Fn? To maintain the car on the road. These two forces are balanced to each other, and also these two forces are equal to each other. But in this case, the two forces are in opposite direction. Okay? According to the equation of coefficient of static friction as you studied in grade 11, mu s is equal to what? Is equal to Fs over Fn. Okay? So, mu s, instead of Fs, is it possible to write Fc? Yes, why not? Is equal to Fc. Instead of Fn, is it possible to write Fg? Yeah, of course. Which is equal to Fg. Fc, Newton's second law for circular motion, is not equal to mac. Fg is not equal to mg. Mass with mass cancel. What is remain? Mu s is equal to ac over g. This is first equation. Equation number 1. Equation number 2 we can get from equation number 1. As you know, AC is equal to what? AC is equal to Vt squared over R. And stated to this equation, mu s is equal to what? AC over G. But instead of AC, write down what? Vt squared over R. What is remain? G. This is second equation. Vt squared over Gr. The third equation came from this equation. As you know, Vt is equal to what? Is equal to omega. What about Vt squared is equal to omega squared R squared? Okay? So, mu s is equal to what? Instead of Vt squared, write down what? Omega squared R squared over R times G. R with R cancelled. What is remain? Omega squared R over G. Omega squared R over G. These three equations can be used to find what? The coefficient of static friction. Okay? So you can screen this proof to more understand. Okay? Okay. This is related for what? This is only for the car when it's moving in a circular path, or for an object rotating on a table, rotated table, when the object is located on the table and the table is rotated. In that case, the object maintained in a circular path because of what? what? Because of the static frictional force. Okay? Okay, guys. We have another case, the case of cylinder. Okay? For this rotated cylinder, the equations are, if you upside down the equation in the first case, you will get the mu s, or the coefficient of static friction for the cylinder. Rotated cylinder, be careful. Or rotor without skidding. When coefficient of friction is given or unknown, use the following equation for what? In the case when the cylinder is rotating. Okay? As you can see in this figure. Okay? As you can see in this figure. Guys, look at me. When this cylinder is rotating, okay? As you know, the gravitational force is always downward. Okay? And the friction between the back of this guy or this person is opposite direction of the FG. This is Fs. For example, when the object touches the wall and moving downward because of the gravity, do we have friction? Yes, of course. Where is the direction of the frictional force? Fs is upward, opposite direction in gravitational force. When a car is moving in a circular path, okay, on the ground, in that case, gravitational force is opposite direction of the normal force. But when the object rotated inside the cylinder, okay, in that case, the gravitational force is opposite direction of what? Fs. So this is the action force, okay, by rotating body. There is a reaction force which is equal to Fn. So in that case, the Fn toward the center, so that is why normal force provided the centripetal force for rotating cylinder. Okay? For rotating cylinder. Okay. Let me draw a figure. This is cylinder, okay? When the cylinder is rotating, because of the inertia, when the cylinder rotating very fast, what happened to this guy? The guy is moving because of the centrifugal force until they hit the wall of the cylinder, okay? So this is action force because of the centrifugal force, and there is a reaction force which is the normal force. Okay, because the normal force toward the center, so that is why in that case normal force provided the centripetal force. Okay, these two forces are equal. But gravitational force, when the rotated cylinder becomes slowed down, what happened to this guy? It's moving downward. Because of what? Because of the gravity. And the friction doesn't lead to moving downward early or very fast. This force is called the static frictional force. In cylinder, Fs is equal to Fg. It's completely different with the previous case. According to the main equation of static friction, coefficient of static friction, mu s is equal to what? Is equal to Fs over Fn, always. Okay? Which is equal to Fs is equal to what? Instead of Fs, write what? Fg. Why? Because they are the same. And instead of Fn, write what? Fc. Fg is equal to what? Mg. Fcg is equal to Mac. Mass with mass cancel. What is remain? Mu s is equal to G over Ac. Opposite the first case. In the first case, AC over G for car, but for cylinder, G over AC. Mu s, Vt square over Gr, but here, Gr over Vt square, okay? If you upside down this, you can get this equation, okay? Instead of R omega squared over G, G over R omega squared. Okay, guys? Look. So this is the first equation, okay? The second equation, from this one. Mu S is equal to G over what? AC is equal to what? Vt square over R. The R is going upward. GR over Vt square, which is equal to GR Vt is equal to omega square R square. Mu S, this is the second equation. This is the third equation, is equal to G over what? Omega square R. This is third equation. Look at third equation, G over omega square R. And already I proved it here. Hope you get benefited, okay?